Hi, everyone. Thanks for joining us today for this pivotal webinar, Insights to Action, Transforming Your Business with Smart Applications. Before we get started, I want to encourage everyone to ask questions of the presenters, which you can do in the Q&A box on your screen. We will answer as many of those questions as we can at the end of today's session. So let's get into the webinar. First, let me introduce today's speakers. Doug Henschen is Vice President and Principal Analyst at Constellation Research, focusing on data-driven decision-making. Prior to joining Constellation, he served as Executive Editor at Information Week, overseeing the publication's big data and analytics coverage. Welcome, Doug.
Hey, Jeff. Great to be here.
Absolutely. I'm Jeff Kelly. I'm a data evangelist here at Pivotal. I spend my time researching, writing about, and speaking about how to put big data analytics into action. Prior to joining Pivotal, I spent several years as an industry analyst covering the big data and analytics markets at Wikibon. And before that, I wrote about enterprise IT and data management as a reporter and editor at TechTarget. So let's move on to the agenda for today's webinar. So first, we'll hear from Doug, who's going to talk about the need to embrace next-generation data architecture. We'll talk about how to democratize the data lake, how to bring insights into action, and how to design for digital strategy. Next, I will speak a little bit about how disruptors use data. I'll talk about some of the challenges facing enterprises when it comes to turning insights into actions. I'll talk a little bit more about 4 key enablers for success, and finally, a recipe for smart applications. As I mentioned, after the presentations, we'll spend about 10 minutes or so answering your questions, which again, you can enter via the Q&A box on your screen. So with that, I'm going to turn it over to Doug, who is going to kick things off. It's all yours, Doug.
Well, thanks again, Jeff. It's great to be here, and it's a great time to be thinking about using your data to drive decisions. So over the last few years, we've seen the emergence of new big data-capable platforms. We've seen the emergence of cloud-based compute capacity and services for developing and adapting applications in a very agile way. Now, together, both of these trends are driving innovation and new business models based on data-driven applications. I'm going to kick off talking about the rise of next-generation data infrastructure, namely things like Hadoop and Spark and NoSQL databases and modern in-memory high-scale relational databases. And that will lead into discussion on my latest research, which is a report entitled Democratize Big Data, How to Bring Order and Accessibility to Data Lakes. It's basically advice to help companies avoid having their fledgling data lakes turn into data swamps. So when the topic is next-generation data platforms, people usually think about Hadoop and NoSQL databases. Today I'm going to talk mainly about Hadoop, which reached its 10th anniversary as an open-source platform this year. Now, over the last 5 to 7 years, we've seen the top Hadoop software distributors collectively win more than 3,000 paying customers for their supported enterprise software. Now, equally significant, and now the fastest growing part of the Hadoop market, are the thousands of organizations using a cloud-based Hadoop service or deploying their own clusters in the cloud. And then there are the tens of thousands of organizations using open source software. Many of those are dabbling, but many are running in production, supporting their own software. In another important development, Apache Spark has blossomed over the last 2 years as a speedy in-memory alternative for both batch and stream data processing as well as data analysis. And it's a move towards low latency use cases that we've also seen through the rise of in-memory databases and database services. Finally, NoSQL databases, which are often deployed in the cloud or delivered as cloud-based services, are increasingly the foundation for web and mobile applications. Now, what all of these platforms have in common is that they are built for data variety and data at scale, relying on massively parallel processing on distributed commodity hardware. Now, adoption of all this next-generation infrastructure would not have happened without proven applications. So let's take a quick look at industry use cases, starting with digital marketing and advertising. Now, I've talked to dozens of companies over the years that are crossing things like web click streams and digital campaign data with transactional records. The internet giants and marketers kind of put Hadoop on the map. And in one of my latest case studies on a company called MarketShare, it fits this same mold. Like a lot of ad tech companies, they're helping to measure the effectiveness of advertising spend across multiple channels. And to do that, it analyzes data from more than 100 customers and thousands of web destinations and social networks. So that's kind of what's happening in advertising and marketing with big data scale. In the financial services arena, JP Morgan Chase was a keynoter and the marquee sort of enterprise customer at the very first Hadoop World event I attended in 2009. Now back then it was about archival storage and low-cost data processing, but use cases have since matured to address really sophisticated analytical applications such as anti-money laundering and stress testing. A couple of months ago at the Hadoop Summit in San Jose, Capital One was the financial services keynoter and premier enterprise customer there, one of them anyways, there were many. It gave multiple presentations on its use of Hadoop and Spark for batch and streaming analytics for applications including real-time loan risk analysis and cybersecurity. In retail, it's not just web retailers that are embracing this next generation infrastructure. At that summit, I had a chance to chat with an executive from Macy's, which launched into big data analysis more than 5 years ago just to power Macys.com. Today, they're also studying in-store purchase behaviors. So for Macys.com, they study web and mobile click streams and overlay product, customer, and preference data. And for stores, they study customer journeys from, say, Macys.com and other search engines, or to brick and mortar stores, or vice versa, from stores back to the .com. And this has helped them to deliver targeted messages to online customers to encourage them to buy in the stores, and to in-store customers with coupons and receipt-based offers to try to encourage them to shop online. Now, the platforms have also given them very deep customer history, something that they couldn't afford to keep on expensive relational platforms. So Macy's can now study purchasing habits and replacement cycles around long-lived durable goods, like beds and furniture, something you replace 5, 10 years. But if you only have 1 or 2 years of history, as we're kind of commanded to do on these more expensive platforms, you can't really study that life cycle. Now, in the latest wrinkle, Macy's is piloting beacon mobile sensor technology to trigger near real-time offers and promotions to customers as they enter the store. So if a customer has logged into the website or has used the mobile app in recent days to browse, say, swimsuits, then the idea is to trigger a related offer or perhaps even direct that customer to the right department the minute they enter the store. Now, this is an example of more of like a prescriptive analytic, where you're using the insight to drive actions, which is what today's webinar is all about. In manufacturing, there's a lot of hype about the Internet of Things, but smart manufacturers have been using sensors and data to drive decision-making for years. So Hadoop now provides a high-scale, low-cost data store so they can keep and use all of their historical data instead of relying on sampling techniques as they might have done in the past. And in the auto industry, for example, early warning detection on defects and warranty repairs used to be a hit or miss affair with sporadic data collection and the use of sampling techniques. So it might take years for a defect to show up. And meanwhile, the manufacturer ends up with hundreds of thousands of vehicles on the road and potentially huge liability if there's a recall. Today, thanks to these big data platforms and infrastructure, we're in the connected car era, and black box data from vehicles is regularly uploaded and analyzed. Ford, for example, studies aggregated diagnostic codes by model and year to spot possible defects and to improve warranty support. Ford is also correlating vehicle data with social data to help product development teams understand what people are saying about new features and performance traits. Now, bringing insights back to the customer, users of the Ford Pass mobile app can remotely check their car's fuel level, its location, and diagnostic error codes. And Ford offers proactive advice on whether to schedule a repair immediately or whether the customer can wait for regularly scheduled maintenance. Here again, an example of something more like a prescriptive analytic. And next generation platforms are behind plenty of breakthroughs in insurance. Now, most notably, usage-based pricing programs such as Progressive Insurance Snapshot. Now, Snapshot is a discount program whereby safe drivers can get better rates if they allow the insured to upload driving data from their cars. And thus far, they've collected more than 15 billion miles worth of driving data. Now, this is a great example of an innovative business model driven by data. And the next chapter is being written by Liberty Mutual Insurance, which has developed a similar discount program, but with a companion mobile application called RightTrack. Now, instead of the insurer keeping those insights to itself, RightTrack will enable customers to see their driving habits, their acceleration and braking, their percent of nighttime driving, their miles driven overall, and most importantly, their discount status embedded directly in that mobile app. And with some car brands, notably Subaru, they're tapping that RightTrack API and embedding those insights directly into a vehicle in-dash display. Now, this is clearly a breakthrough, and I understand Progressive is going to respond with its own customer-facing mobile app and offering embedded insights API style. So now let's turn to the state of big data management. Now, to support the types of data-driven applications I just described, it's essential to have next-generation data infrastructure that can support both big data scale and production data pipelines. Now, Hadoop, used in combination with the latest streaming, relational, and in-memory technologies, is such a platform. But the danger is that things can get messy. The rough idea of the data lake is to serve as a first destination for data in all its forms, including structured transactional data and unstructured and semi-structured data, such as log files, click streams, email, images, social data, and text documents. Now, the data lake can handle it all, but despite myths to the contrary, you can't just dump everything into this lake and trust that you'll be able to find and effectively use that information. That's why it's so important to have a well-planned data architecture. So, for example, you want to ingest and retain raw data with enough tagging to know what it is and where it's from. You'll want zones for refined data that has been cleansed and normalized for broad use. And you'll want zones for application-specific data that you might develop by combining data from multiple sources. Now, here's what a few executives I've talked to recently had to say about their Hadoop-based data lakes. A digital marketing executive said, "Better data governance is the #1 priority on our wish list." A logistics company exec said, "Hadoop was messy on the data lineage end." And an aerospace exec told me, "We want better ease of use for business users." That company has only 3 people who understand Hadoop and 150 business users who need access and need to analyze that data. This last wish is a perfect case for injecting data-driven insights and recommendations directly into applications. Now, big data pioneers and fast followers know that Hadoop still has gaps in capabilities and some primitive coding-intensive tools. But the good news is that we're seeing a rich ecosystem emerging with many open source contributions and commercial vendors working on data management and governance, data cataloging, metadata management, easier data discovery, and prep. Now, all of these topics are discussed in my Democratize Big Data report, and we'll share a link to that research later in the webinar. So once you have your data lake in order, it's a reliable source for high-scale data. There's a desire to make that data accessible to more than just Hadoop experts. So starting in about 2014, we saw this explosion of SQL on Hadoop options. Over the last year or so, we've seen OLAP on Hadoop options emerge, including AtScale and Arcadia and Kivos, and some open source options, including Druid and Keylin. Now, all of the above democratize the data lake by exposing Hadoop data to BI and data analysis tools. But as I'll discuss in a few moments, these tools haven't really managed to bring data-driven insights to most business users, let alone to customers. So your SQL savvy types are more common than the Hadoop experts, and people who can handle BI and data visualization tools are more common than SQL jockeys, but we're still not talking about bringing insights to the masses. With prescriptive analytics, you deliver these insights and recommendations within the applications that business people and even customers use every day. Another important point is that you should not think of a big data platform as a high-scale replacement for a data warehouse. Yes, the data lake should support SQL-centric analysis, but if you're not tapping new data types and coming up with new types of insights, you're not really taking advantage of that next generation platform. And here I'm talking about advanced analytic approaches like time series and path analysis for understanding customer behavior, machine learning for automatically spotting correlations and exceptions in data, deep learning for understanding language and sentiment and images. This is where previously untapped data types and the next generation platforms go hand in hand. So it's a shame if you're taking the same old sort of SQL-centric reporting and query approaches on a platform that can do much more. Now, people talk about the center of data gravity, which is about where the bulk of the data will be stored. Now, volume-wise, that's clearly shifting to these new platforms, but I believe it's also important for companies to consider their center of analytical gravity. For example, data workloads might move to Hadoop, or they might remain in relational environments for many years to come. Companies might move advanced analytics to Hadoop or Spark, or they might choose to handle these workloads on a distributed database or an in-memory grid. The question is, where will the bulk of the high-value analysis take place in your organization? And as we'll explore next, how can you share insights with as broad a community of users as possible? So some of the biggest trends in tech these days have to do with democratization. You hear about the consumerization of enterprise tech, making it consumer-friendly. You also hear about self-service, liberating the many from the dependence upon the few experts. In business intelligence, we saw vendors like Tableau and Qlik disrupt incumbents like Business Objects, Cognos, and MicroStrategy. Today, we hear about self-service data prep vendors like Pexata and Trifacta, liberating us from dependence on IT and complicated ETL tools. In the area of advanced analytics, three approaches to self-service have kind of emerged. First, there are products that focus mainly on self-service BI, also known as descriptive analytics, that are adding sort of basic predictive capabilities. Examples here include Business Objects Cloud, IBM Watson Analytics, Microsoft Cortana, ClickSense, Tableau, many options. The second category is self-service products that offer the basics of BI but are mainly focused on advanced analytics, and products here include Alteryx and SAS Visual Analytics and TIBCO Spotfire and a number of others. Now the third trend, and the one that I believe and many believe has the best potential to reach the broadest base of business users, is the move to prescriptive analytics. You're going beyond predicting and delivering a data-driven recommendation or even an automated action within the context of an application. So most think of this move from descriptive analytics to predictive analytics to prescriptive analytics as a progression in maturity, and it is, but all three types of analytics are valuable and have their place. Prescriptive analytics, though, offer the best shot at true democratization because it's about embedding and contextualizing recommendations and actions. Now, with prescriptive, business users or customers don't have to leave their usual applications to go look at and interpret a dashboard or a KPI or a chart. or they don't have to look at a prediction and kind of figure out, which prediction is most likely to come true and which one do I want. Instead, they see concise recommendations or suggested actions right in the application. And when there's high confidence, you can even automate those actions. So how can you act on insight in the context of an application? One example would be a bank lending application with built-in risk analysis. You could have that app automatically take action by either accepting or rejecting a loan applicant based on fixed rules around, say, their FICO score. Alternatively, you might deliver an array of recommendations, giving loan officers some discretion to ask for, say, a smaller loan amount, or a higher down payment, or a cosign, or some other option. The point here is that with prescriptive analytics, you can design them and test them and optimize them for best possible outcomes. Now, let me back up a sec here. With prescriptive, there's this opportunity and often a requirement to be more sophisticated, because the assumption is that you're not dealing with an expert user. So if you're going to offer a recommendation or a suggested action, you better be right. And in cases where you're automating actions and not even having a human in the decision train, you simply have to be right. This is where the next level of analytics comes in, whether it's optimization algorithms or simulation or modeling of outcomes to test and be sure that your recommendation or suggested actions are the best choices. Now, another benefit of taking a prescriptive in-app approach is closing the loop. If you can record and track the outcomes of your decisions, you can use that data to inform future decisions. Now, this creates a learning system that can sense and respond to changes over time. Now, prescriptive and cloud go hand in hand because SaaS and other cloud-based delivery models make it easier to create agile, data-driven apps that close that loop and automate the delivery of insights and recommendations through cloud-based services delivered through REST APIs. So what are some examples of applications that are a good fit for prescriptive analytics? Now, in general, the higher the frequency of a transaction or decision, the higher the value, and the higher the value or the higher the risk tied to that transaction, the more likely you are to see a payoff in doing everything you need to do to deliver prescriptive recommendations or actions. In healthcare, medical screening apps flag patients that might be susceptible or brewing some sort of sepsis or some sort of infection. In prescriptive insurance apps, you can do things like spot claims that deserve fraud investigation. In retail, it's now common to offer cross-sell and upsell recommendations based on current basket selections as well as past purchase histories. And in manufacturing, data-driven apps are tying production to demand forecasts. In supply chain, prescriptive apps are suggesting best fit alternatives when there are disruptions from incumbent suppliers. So now let's zoom out to a bigger picture and consider business opportunities. Now, Constellation Research estimates that 60% of mission-critical data will reside outside of your company's four walls by 2020. Now, even if you have a massive data lake, that's only part of the story. So much of the data you need and will need will be accessed rather than owned. So you have to develop a data integration strategy that is cloud, services, and data enrichment ready. Now, just part of the reason that so much of our data will live outside the four walls of our organization is the cloud adoption trend. With so many of our applications now running in the cloud, much of our data is naturally being born there. Now, another reason for the shift to data outside of the company is the fact that so much of the context of our interaction with customers, the reasons for their behaviors, is happening out there in the real world, not in our systems. It could be the weather that they're experiencing, or the traffic jam they're sitting in, or the mall they just entered, or the comment they just posted on a social network. So much of our success depends on outside forces that we might have thought about in the past, but we seldom measured before we got into this modern big data era. Now that's a big change, and from here on out, all of the contextual data will be part of the analytical mix. Now, I'd encourage you to consider opportunities for new business models and monetizing your information. Now, at Constellation Research, we see three broad data monetization strategies. The first is information-based differentiation, whereby companies like Progressive Insurance have services such as Snapshot, and where companies like GE are improving the efficiency and performance of their jet engines and locomotives, and they're selling them as services rather than, fixed assets. It's jet engine as a service, locomotive as a service. Now, the second data monetization strategy is information-based brokering. Retailers, for example, have long sold their point-of-sale information to data aggregators like dunnhumby and Nielsen, but giants like Walmart and Amazon and Macy's have become their own data aggregators. In fact, even very small companies like the wedding planning site The Knot are embracing this model. The Knot is selling aggregated data on the choices brides are making by age, region, and city to fashion houses, to home goods manufacturers, and to hotel and travel businesses that sell honeymoon packages. Now, the third data monetization model is about creating information-based delivery networks, and that's where you'll need the ability to deliver insights as services. Uber, for example, uses this spot trading capability to sell excess capacity for package and pizza delivery. So keep in mind that big data and social and mobile and cloud are starting to look like old hat. The emerging trends including things like Internet of Things and 3D printing and robotics and artificial intelligence. But that doesn't mean that you no longer have to address what came before. Those capabilities are becoming table stakes and building blocks for the developments to come. Big data analysis, in-memory and streaming technologies, and prescriptive analytics are key ingredients of data-driven applications. And these sorts of apps are driving disruptive new business models. And I'd sum up by saying it's up to you, it's up to your organization, IT, the business working together to stay ahead of and to harness these trends. And with that, I'm going to hand things back to Jeff.
Okay, great. Thanks, Doug. That was a fantastic presentation. I think that provided a really good perspective on kind of the need to operationalize big data analytics and turn insights into actions, and certainly some opportunities to think about if you're an enterprise practitioner. So now I want to give the pivotal perspective on this topic and how we approach this with customers, helping them turn insights into action. And you'll see some parallels with Doug's presentation. I think we're right on when it comes to some of the trends we're seeing in the market. So now if you're familiar with Pivotal, the company, you know that our mission is to transform how the world builds software. We're bringing both the technologies and the approaches to software development used in Silicon Valley to mainstream enterprises around the world and across industries. And our goal really is to help all our customers become great software companies. So if you look at the disruptive companies out there, from whether it's the big web companies like Google and Facebook, or maybe the second and third generation web companies out there like Uber, Airbnb, they all have a few things in common. One, of course, is that they use software to develop and deliver exceptional experiences to their customers. So really at their heart, these companies are great software companies. But if you dig a little bit deeper beneath the surface, another trait they have in common is that they all use data to fuel and power their software and applications. And they use a lot of data. Just to give you some examples, Doug talked a little bit about Uber a moment ago. So Uber processes data associated with hundreds of thousands of trip events every day. Another company you're probably familiar with and perhaps a customer of, Netflix, who processes over 400 billion viewing-related events or transactions each day. And then Airbnb processes and analyzes over 5 billion training points just to support one feature in its application. But how these great software companies use data goes well beyond simply producing traditional business intelligence reporting and dashboards that tend to be backwards looking. In these companies, data and insights generated from analyzing data manifest themselves as features in their applications. So in the case of Uber, it's crunching massive volumes of data, trip data and other data to produce fare estimates, to produce estimates on pickup times, for example, things that you actually, as a user, see in the application itself and can use that information to take action and make decisions. In Netflix, another great example uses data science and big data analytics to personalize the movie and show recommendations that you see in the application, which drive over 75% of all viewing on its platform. And of course, that's really important to the customer because it's going to provide them with great content to watch, and it's really important to Netflix because the easier it is for customers to find things they enjoy on Netflix, the more likely they are to stick with the service. And finally, Airbnb, as I mentioned a moment ago, so they're analyzing over 5 billion training points to produce its price target feature, which is a feature really that helps renters accurately price their homes and apartments to maximize the likelihood it gets rented. So to put this another way, really what it boils down to is great software companies like these leverage big data to fundamentally change the user experience and pioneer entirely new business models, including some of those you heard Doug talk about earlier. So we at Pivotal believe the same opportunity to use data to drive new value is available to all enterprises across industries. In fact, we believe that leveraging data this way is really a requirement to compete in this emerging digital economy. So as Jeff Immelt said, CEO of Geo, as he put it, if you went to bed last night as an industrial company, you're going to wake up in the morning as a software and analytics company. And I'd argue you could take the word industrial in that sentence and pretty much change it to any vertical industry, and the sentence still applies. Now the problem is most companies really aren't ready to embrace this approach yet, and that's for both technology-related reasons as well as more what I'd call people or cultural reasons. So from a technology perspective, traditionally in most enterprises, their operational systems or transactional systems that support enterprise applications tend to be somewhat isolated from their data warehouse and business intelligence systems. So they're usually connected only by some kind of monolithic batch ETL processes where data generally moves just in one direction from those operational and transactional systems to the data warehouse systems to produce those backwards-looking reports and dashboards we talked about a moment ago. Now, just as important, and really not surprisingly, the developers that are building these enterprise applications, they rarely think about the role data and analytics might play in their applications. That's just not the world they tend to live in traditionally. And nor do they interact with data professionals very much either. But I don't want to pick just on developers because the reverse is also true. So for data professionals, those who administer data warehouses and build out reports and other types of analytics, these data professionals generally don't give a lot of thought to how the insights they're helping to produce might actually be used in applications to deliver real value to users. Nor do they spend a lot of time collaborating with developers trying to figure this out. So both these challenges, we believe, need to be overcome in order to really put analytics and data science to work as we've described earlier. And then if you zoom out just a little bit more and kind of take a look at the larger infrastructure that we see in most large enterprises anyway, what they're dealing with, it looks something like this. It tends to be a mess, frankly. You've got siloed and aging database systems, you've got spaghetti data pipelines, a lot of expensive proprietary systems, monolithic application architectures, as I mentioned, batch-oriented data integration, and certainly a lack of collaboration between application developers and data professionals. So this really isn't conducive to putting data to work. So how do these great software companies we talked about earlier, how do they actually accomplish this? How do they actually turn insights into action? Well, we at Pivotal see 4 major enablers that companies, we believe, need to embrace to really take advantage of data and turn it into actionable insights that can really drive value for their customers and themselves. The first is open source database innovation. So this is where big data comes into play. So it's simply not possible to store, process, and analyze the volume and variety of data at play today with traditional data warehouse and database technology. And Doug did a really good job talking about some of the trends we're seeing in the market that have happened over the last 5 to 10 years with the rise of different types of big data technologies that really allow you to tap into a much larger and varied types of data. So really, in order to take advantage of this, enterprises really need to embrace open source database innovations. So it's technologies like Hadoop and NoSQL databases and even MVP analytical databases that really enable the extreme scale and performance required to handle true big data. And interestingly, virtually all of that innovation is originating with open source communities. And that's another big change from traditional enterprise software development. And that, of course, could take up a whole webinar in and of itself. So the second enabler we see out there are cloud-native platforms. So cloud-native platforms are key because they enable continuous software delivery and automated operations. And this, in turn, supports the agile application development process, as well as agile data science, frankly, required to continuously learn and iterate your applications as you gather feedback from your users. Third, data microservices. So again, we could certainly spend an entire hour or longer talking about microservices. It's a really hot topic today with developers. But what I want to talk about today is really fundamentally to understand that microservices allow developers to create loosely coupled data pipelines that feed data to applications. So by loosely coupled, I mean that these data microservices are not baked into the application architecture and can be modified independent of one another and other services, and they can also be consumed by multiple applications. They can be reused. And this is really key to operationalizing big data in the terms of applications. And finally, the fourth is machine learning and data science. So put another way, that's all about mining vast amounts of data from multiple sources, different types, different varieties of data that we talked about earlier, to glean patterns and build predictive models. It's those models that are then operationalized into applications that produce the timely and accurate predictions, or it could be a suggestion or an estimate or whatever insight that really adds value to your application and improves the user experience. So now when we zoom out a little bit more, what we see is these four enablers result in a modern cloud-native data architecture. Now contrast this with the earlier image we were looking at around the current state of most enterprise infrastructure today, and you'll see clearly this is a dramatically simpler, but more powerful architecture. So a few things I just want to point out here, and of course this is a conceptual model. This isn't the detailed technical architecture, but I think this should get across the general idea of what we're talking about when we talk about cloud-native data architecture. So notice that big data and machine learning systems are not isolated from applications, as well as the microservices and persistent data stores that support them. They're integrated into the larger platform where data moves back and forth between systems. Data and insights move back and forth between systems, enabling you really to apply those predictive models in real time in your applications. And from a pivotal perspective, we offer both an infrastructure-agnostic cloud-native platform called Pivotal Cloud Foundry, upon which to build these applications. We also support a set of tools called Spring, which really support this agile application development methodology, and are also key to creating these data microservices or data pipelines to feed your applications. And of course, we also offer a suite of open data technologies to support both your transactional and operational applications, as well as your big data analytics and machine learning needs. So I mentioned earlier that in addition to some of these technology challenges that a lot of enterprises are trying to overcome today, there are also a number of people, or what you might call cultural challenges, that enterprises face. And so really, in our opinion, to really become a great software company that uses big data to drive new value, in addition to adopting new technologies, enterprises also need to shed old ways of thinking about software development and embrace a new set of tenets that include bringing data into the equation. Now, among these, well, let's look back actually. In the past, so traditionally you would assume that your infrastructure was hardened and reliable. You assumed you were going to release code every 3 months or so, perhaps longer intervals. And you were really only concerned that your applications worked in your own environment. And of course, that your applications and services and data stores, they were tightly coupled into these monolithic application architectures. They couldn't really be taken apart without impacting other parts of your application. So today you need to adjust your thinking. Today, in order to take advantage of new approaches of software development and big data, you need to think about things like your infrastructure is going to be fragile. So in web scale environments, hardware fails and you need to plan for that. You need to release code early and often. This is all around agile development that we talked about a little bit earlier. Another thing that goes right along with that is DevOps. So development and ops need to share responsibility for the success of applications. Another thing we touched on, developers and data professionals really do need to collaborate in this new environment. And finally, you really have to adopt an architecture where your applications, your microservices, and your databases are loosely coupled. So now I want to look a little bit closer at how smart applications really work. And we see this as a 4 or 5 step process that we affectionately call a recipe for smart applications. So let's get started. So step 1, when it comes to your recipe for smart applications, is engagement. So not surprisingly, the key ingredient of any smart application is data, in this case, usage data. So this could include data that users create explicitly. So that could be, for example, transaction data, so created when a user makes an order or a purchase in an application. Or that data can be created implicitly, such as clickstream data users leave behind as they navigate throughout your application. This is also sometimes called data exhaust. So step 1 really simply is just to develop applications that really encourage continuous and frequent user engagement in order to create large volumes of usage data. Step 2 is to capture, store, and process all that usage data, combining it with other data sources if needed. So what does this require? So this requires building data pipelines to move all that usage data to some type of operational database or data grid layer. And it also must be landed in analytical data stores for further analysis. So, the type of operational database or data grid you might be working with, could be an in-memory data grid, could be a key value store, could be a relational database. And the analytical data store you're working with could be anything from Hadoop to your MPP analytical databases to in-memory databases, any number of options. It really depends on the use case, data structure, and data volume, some other requirements, other considerations, I should say. And it's going to be different for each scenario. Step 3 is to create predictive models. So now you've got usage data captured in some type of analytical data store, some type of analytical platform. The next step is really to analyze that data to develop predictive models that can generate actionable insights. So data scientists often enrich application usage data with other data sources that contain predictive value before they build their models. So other data sources could include historical application usage data, could be other types of customer data, it could be some of the outside data. As Doug mentioned, a lot of the important data that has predictive value actually is generated outside your 4 walls, outside the walls of your enterprise. That could be demographic data, could be weather data, financial market data. Any number of data sources, depending on the use case, can add predictive value to your models. But the important part of this step is that the end result are working predictive models, because once you can predict an event, then you can optimize a decision. And the most important step, of course, step 4, is to suggest. During step 4, predictive models are actually applied to live discrete application usage data in real time to generate actionable insights. So by discrete application usage data, I mean data associated with a particular user session as is happening. So once models are applied and actionable insights are created, these insights are then surfaced back to the application in a form that is useful for and actionable by the user. So again, this could take any number of forms. It could be a suggestion for the user to take. It could be some kind of estimate of an upcoming event. But whatever it is, the goal is that it provides some type of insight in the context that a user can either take an action or make some type of decision based on that information. And finally, rinse and repeat. So, unlike a recipe for, oatmeal cookies, a recipe for smart applications is never finished. You've got to repeat this process again and again. And each time you do that, you're improving the insights and you're improving the user experience. So really, at the end of the day, to be a great software company that leverages big data effectively, we really think you need to be able to answer yes to most of these questions, if not all of these questions. So questions like, can you consume a wide range of data sources and protocols? Can you modify data pipelines and add processing steps frequently at runtime? Can you ask lots of questions of your data? Can you update algorithms and models daily? Can you build cloud-native data microservices? And can you release new features in minutes multiple times a day? So finally, how can Pivotal help? So we work very closely with our customers to do a number of things, to modernize their data platforms with the goal of improving performance and scalability for their mission-critical data workloads and lowering their overall TCO by adopting industry-leading open-source database technologies on a modern cloud-native platform. We'll also help prove out a specific business use case, so at the end of the project, you're left with a working smart application delivering real value. So we work with our customers to build data microservices, automate ingestion and data pipelines, apply machine learning to build predictive models, and ultimately, they result in a smart application from end to end. And I think just as importantly, through our Pivotal Labs organization, we'll also teach you how to carry on, how to adopt these practices internally at your organization so that you can carry on building new and innovative smart applications long after the Pivotal engagement has ended. So with that, I'm going to conclude my presentation. I hope it was helpful, both Doug's presentation and mine, to your understanding of smart applications and how they can add value. Now we have a few minutes for Q&A, so if you haven't asked a question you'd like to, you can do that in the Q&A box, I believe on the right side of your screen. In the meantime, I think we do have a few questions in there already. A couple for Doug, so why don't I cue these up, Doug, and if you're ready, I'll fire away.
Sure thing.
So the first question we have is, how will real-time and streaming technologies change prescriptive analytics?
Well, the short version is it's going to create opportunities, but it's also going to create a more demanding environment for what you do with analytics. So you can do real-time applications. That's great, but what if the analytics are a day old? Are you going to recommend a product that a customer purchased 2 hours before because you're stuck at overnight batch updates? So, you really have to, if you're aiming for a real-time capable application and you want to deliver insights of any sort in the context of that application, you really have to think about the sorts of recommendations you're making and whether those need to be as real-time as the application itself. Fortunately, the emergence of all this streaming technology is making it easier, as Jeff sort of described, these data pipelines, these real-time data pipelines that can give you, the low latency insight to go along with your application.
Great. So now we've got a question about kind of how to get started. Is it important to get started collecting data right away, or should you really focus on a specific business use case, business problem when you're starting your big data practice? Great question. I would argue that I think it's more important to focus on a discrete business problem. I think one of the challenges we've seen in this market, in this industry, among early adopters anyway, was, where there's a lot of hype around technologies like Hadoop, for example. So a lot of people, a lot of enterprises invested in it. And the result today is they've got data lakes or Hadoop deployments sitting around with lots of data in it, but really they're struggling to figure out how to use all that data, how to analyze it, and what business problems to apply it to. So at Pivotal, when we work with clients that are new to big data, we recommend figuring out or determining one or two really important critical business problems that you've been challenged and struggling with, and business problems that you have data associated with that could actually be analyzed to help solve that problem. When you have that problem identified, then you can go start to invest in the technology and the processes and the development to actually build applications that hopefully will successfully solve that problem. And that tends, in our experience, to be the better approach. You get a quick win. It spurs interest in using big data to solve other problems, and it can quickly spread through the organization, rather than having a pristine Hadoop deployment but not getting a lot out of it. Doug, I'd be curious to get your opinion on that.
Yeah, totally agree with you, Jeff. It's not build it and they will come. People succeeding are starting with value delivering concise business problems, and the messy lake phenomena I talked about sort of emerges over time as more and more applications emerge. If you haven't addressed the sort of data management aspects of Hadoop, that's when things start to get messy. So I agree, it's not create the perfect data lake first. Start with specific problems and specific data that addresses that. But just keep in mind that as applications multiply, that's where the problems of the swamp-like condition and not being able to find and use and capitalize on your data, that's when that problem emerges.
Absolutely. So another for you, Doug. So what is the difference, the questioner asked, what is the difference between embedded analytics and I believe it's prescriptive analytics?
Right. I showed the chart in my prezo showing descriptive, predictive, and prescriptive. It's possible to embed any and all of these in an application. And we see examples of this, particularly embedding a KPI or embedding a dashboard or embedding some sort of data visualization. That's very common. But the downside is that the user has to know how to read and understand and use that dashboard or the KPI or the report. If it's a little bit more sophisticated and it's a prediction of some sort, they have to know how to make use of that prediction, or that prediction has to be simple and clear enough that it's obvious what you need to do, so that the idea of actionable is relative to the user. With prescriptive, the idea is very immediate decision making and really no time for interpretation, and the understanding that the user is maybe the customer or an untrained or simply trained CSR or what have you. The assumption is that you're providing sort of a concise, tested, and proven recommendation or action. That's when you're embedding a prescriptive analytic, as opposed to showing a dashboard and leaving it up to the user to have the wherewithal to make use of that, to make that insight actionable.
Great. So we've got a question asking if we could elaborate a little bit on the kind of the collaboration we think that needs to happen between application developers and data scientists. So, I would just add that in order to kind of enable that collaboration, I think it helps if both organizations, both groups have adapted, I should say, kind of these agile methodologies where they're used to creating data, analyzing it, and moving that feedback back into their application or back into their analytic platforms. So I think that's one area. But if you look historically, we've come a long way. The developer community has come a long way in the sense that, they've developed these agile methodologies, these modern approaches to building software, and we see the fruits of that in the big web companies, and we're starting to see that more in the enterprise. On the data side, we see on these new technologies emerge around Hadoop and other ways of crunching big and varied data. The problem is those two things haven't kind of crossed the chasm to one another. So I really think they need to, data scientists and data application developers really need to develop working relationships so that they're both, thinking about the needs of the others. They have some empathy towards the goals and the jobs of the other group. When that happens, then more collaboration becomes a little bit easier. It's certainly not an easy problem to solve. Doug, I'd be curious what your feelings are about that.
Yeah, two things. First of all, I do think, the term is agile analytics, and I think the analytics and data science professionals are hip to it and embracing it And that's why you see things like in-memory databases and Spark, other in-memory technologies, and certainly streaming technologies emerging, being embraced and talked about a lot. So I think the data science community is hip to the real-time demand. And yeah, I think it's a matter of structuring and cultural difference in the org. I see organizations where they have this sort of hybrid organizational approach. A good example is at Facebook. They're distributed and centralized. So there is a head of analytics, and all the analytics guys and gals, all the professionals in the organization report up to him. But they are on projects. They are all on project teams. So they also report to these project and sort of line of business teams. So it's hybrid in that they're part of a line of business unit. They report to the line of business, but they also collaborate with that and report to that head of analytics, who can see, hey, these two analytical projects that are happening in this business unit and that business unit are very similar. Or, hey, this really cool project that they're doing over here is going to be applicable here, here, and here. So, that's a really good example of where a structural change can really facilitate this collaboration between the developer gangs and the data science gangs.
Great. Well, everybody, I hope you enjoyed today's presentation and our Q&A. We're just about out of time, so we're going to wrap up now. Keep in mind, we'll have a replay of this presentation available shortly, and you'll also be able to download the slides. And with that, we thank you for your time today. Thanks for joining us. Doug, thanks so much for presenting today. Really great insights.
Thank you.
And we'll see everybody next time.